Hey students, we're going to try on the in-class assignment 8.6. This is number 5 and it's about the Super Lotto. We're going to calculate all these odds about the Super Lotto, California jackpot, and now you can find out exactly what an improbable event it is to win the Super Lottery, right? Alright, so here's how Super Lottery works. There's 5 balls. We're going to call them lucky balls, and they, there's 47 lucky balls, and we're going to choose 5 of them. Each ball is going to have one of the numbers 1 through 47, and once a number is placed, it doesn't get put back into the bin, if you will, so we do it without replacement. And then in a separate bin we have the mega numbers, and those are going to have the numbers 1 through 27, and we're just going to draw one of those. So just if you've never seen the lottery before, for instance, what could happen is maybe the first ball was a 13, and then an 8, and then a 41, and then a 32, and then a 33. And then the mega number is, are you excited? What number did you choose? Well, the number was 21. Good try. Better luck next time. You were so close. So in this case, the winning numbers were in order, because we don't care which order these were drawn in, because you're just gonna take all these numbers and not have to put them in order. Sorry, it doesn't matter what orders they were selected in. So these winning numbers, this particular drawing would have been 8, 13, 32, 33, 41, and the mega number 21. What? That's what you chose? Ooh, you're a billionaire. You owe me some money. Alright, so I'm kind of paraphrasing the questions here, but hopefully you've done or at least tried your in-class assignment. And let's see part 1. How many possible winning numbers are possible? So if you recall, we're going to have 5 numbers here, any numbers 1 through 47, and then we're going to have one number 1 through 27. So there's just one of them. And remember, these numbers were 1 through 47, and we could choose 5 of those in any order. So what does that make that? That makes that a combination. In fact, it's 47, choose 5. Now that's just the first numbers, the first 5 numbers, the lucky numbers. How many ways are there to get to the mega number? Well, we're choosing 1 out of those 27. So amazingly enough, it seems very complicated, but now that we know all these fancy things like combinations and permutations, it's, I don't want to say just as simple, but it's just as simple as getting out our calculator and multiplying 47, choose 5, times 27, choose 1, which is 27, but when you multiply all those numbers together, we get 41,416,353. Now this was doing the combination way. If you prefer the permutation way, I showed this on the solutions to the homework, but I think combinations are easier. But if you want to try this with the permutations, for instance, there's how many different orders could you draw the first 5 numbers out of the 47 possible? Well, it would be 47 times 46 times 44 times 43. Now, since we didn't care about the order, there's 5 numbers. There's 5 factorial possible arrangements of those 5 winning numbers, and then we need to multiply that all out by the mega number. There's 27 different mega numbers, and had you done this, you still get the same thing as above. Sorry, I'm running out of room there. So, long story short, there is 41.4 million different possible combinations of numbers you could possibly choose from, or that could possibly come out as winning numbers. So part B asks, what's the probability of winning the jackpot? And winning the jackpot, you have to match all 5 numbers. Well, there's only one way to match all the numbers, since we don't care about the order anymore. The order was taken care of when we came up with this number on the denominator. So your odds of winning are literally 1 in 42.4 million. Good luck with that. So what about if we want to do part C? There's lots of like secondary prizes you could win on the lottery as well. Like if you match all 5 numbers but not the mega number, you can win some money. So let's find out what the odds are that we that we match all 5 numbers, but not the mega number. So here's how I would set up these next problems. We're going to have, like, for each mega number and for the for the lucky numbers, we're going to have 5 winners, which is going to make, remember there are 47 in total, which is 42 loser number. 5 winning numbers, 42 losing numbers. So in this case, and same with the mega number, we're going to have 1 winner out of the 27 and 26 losing numbers. Sorry, numbers, I don't mean to call you losers. No hard feelings. Okay, none taken. So if we want to, so this is the way you want to think about these next upcoming problems. There's always going to be 5 winning numbers and 42 losing numbers, lucky numbers, and there's always 1 mega number that's a winner, which means there's 26 losing numbers. If you think about like this, actually the rest of the problem, I don't want to say is dreadfully easy, but it actually simplifies things quite a bit. For instance, if I want to find part C asks for matching the 5 lucky numbers but not the losing number, well, there's how many ways could let's see, so I'm choosing, let's put this with the lucky numbers, I'm choosing out of the 5 winning numbers, I'm trying to choose all 5. And of all the mega numbers, there's 26 losing numbers, and I'm trying to choose 1. So of all the ways, bye Don, or Mrs. Brander, I'm recording, so I'm not talking to myself. Okay, I'm talking to myself. I'm kidding, I'm not. It's Friday, it's after school, you guys are all having fun, and I'm still working. Not fair. Then again, I get paid for this. But wait a minute, I had to go to high school too. That's not fair. So if we crank out all these numbers, let's see what the numerator ends up being. I even overthink it sometimes. The numerator is 26 because there's only one way to choose all 5 numbers. That's 5 choose 5. And there's going to be 26 ways of choosing the 26 losing numbers. So the odds are going to be 26 over 41.4 million. Now, a little trick on the calculator, what you can do, if you go ahead and divide these numbers, let's go ahead and divide 26 divided by 4.1 million, and I get like a, whatever number it is, on my calculator I got 6.27 negative 7. Now, what I'm going to do here, so I got, move that, I got this number here on my calculator, 6.277 or times 10 to the negative 7th. If I kind of take this inverse, so I'm going to hit that that button to the negative 1, what I end up getting, I'm not talking to myself, I swear. So if I hit this inverse button, I get this number 159.2. Oh man, that's a lot of numbers. 52936. I'm gonna leave the decimal, but what that means is that I have about a 1 in what is that? 1.5, almost 1.6 million chance of matching all 5 regular numbers, but not the mega number. So close. Okay, what about if we want to match 4 out of 5 of those numbers and the mega number? Okay, so let's remember again, we're going to have 5 winning numbers, 42 losing numbers. So of those winning numbers now, I need to choose, so I'm going to choose 4 out of those 5. So 5 choose 4 of the winning numbers, but that also means I got to choose one of the losing numbers. So out of those 42 losing numbers, I have to choose 1. And then I'm getting the mega number right. There's only one way to choose the mega number right. That's to get it right. 1 choose 1, if you will, or just 1. And I could divide all that by our fancy denominator, which I'm starting to memorize. And I just want to see what that numerator is. 5 choose 4. I'm going to pause it, put it in my calculator. So I got 210 on the numerator divided by that. And again, if I put that put that on my calculator, actually try to divide that, and then I'm going to hit the inverse button, and that's going to give me a number. This is going to tell me that I have about a 1 in 19722, about a 1 in almost 200,000 chance of getting exactly 4 out of 5, and the mega number. Hey, this is easy so far. Try part E. Pause it. Try it. I did this. I was just telling Mrs. Creighton about this. I got 3 out of 5 numbers and the mega number correct one time. The jackpot was like $200-something million, and I was like just 2 numbers off of being a millionaire, right? A total millionaire. So pause this. See if you can try this. Use the method I was using. Okay, welcome back already. Okay, you didn't actually pause it, did you? Oh, you did? Oh, thank you. Thanks for trying. All right, so this time we're going to have 3 winning numbers and 2 losing numbers out of the 5. So how many ways out of the 5 winning numbers we're choosing 3? And of the losing numbers, we're choosing this time 2. And of the mega number, we got that right. There's only 1 mega number, so again, that's kind of 1 choose 1 or just 1. And we'll divide all that by our fancy denominator, 41 million something 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 something. And I'm going to pause that and put that on my calculator. And I got 8,610 divided by, again, I'm not going to rewrite that number, divided by that. And if I divide this, I can actually make a little bit more sense of this number, 0.00207, or about a 0.02% chance. And if I take the inverse, I get about 1 in 4,810. Sorry, 4,810. So what I did, I'm pretty proud of myself. I mean, not that I actually, it's just pure random chance, right? But hey, I got something, and the odds of me doing that particular day were 1 in nearly 5,000. Hey, that's not bad. I won like $50. Like, really? That's it? Maybe it was $60, but I was still disappointed because it was like a $200 million jackpot, and $60. Well, take somebody out for dinner with that kind of money. Alright, and we got the sad face here, part F. What's the probability we don't get any matches? So in this case, we're going to have 5 losing numbers and 1 losing mega number. Well, how many losing numbers were there? There are 42. I'm going to choose 5 of those 5 losing numbers. And there are 26 losing... there were 26 losing mega numbers, and I'm going to choose one of those. And again, that's all over my fancy denominator here. It is a fancy denominator. So let's calculate this. This time I get a big number on the numerator, as I'd probably expect, right? And there's a fairly decent chance that I don't match any. 6.8 divided by, that. I'm going to put that in my calculator. And I'm a little surprised. Are you a little surprised? There's actually only a 53.4. I say only because there's a 53.4% chance that you don't match any of the 6 numbers. And that sounds, almost high, right? So it looks like you're probably likely to get at least 1. In fact, I could even do one more on this. If I take 1 minus that number, then what am I getting here? 4, 6, 6. So there's actually a 46.6% chance that I match at least one, have at least one match, and that could be any of the matches. You don't get any money for having 1 match or 2 match. I think you get $1 or like a free ticket if you win the mega number. That's a 1 out of 27 chance of that happening. But hey. Yeah, it's pretty cool, right? Now you're all professional combinatrix mathematicians. So go out there and prosper. All right, guys. Thank you.